Alright, I know in this class we're all here, but for any of our friends playing along at home, it is Tuesday the 22nd. We won't have this math class tomorrow because you guys will have double connections. We're doing triangle side lengths first and then talking a little bit of cross sections. So we are in Desmos, working on triangle side lengths. We're looking at all of our notice and our wonder. I like that question. I wonder how long does the set have to be to make a triangle? Just reading some of your guys' notice and wonders. So here's what really happened. Womp. Yay! Oh, now I do understand, Lydia. I'm looking for my little So even laid down completely flat and no longer a triangle. So this is seven, right? And this is flat. Okay, we lay it down flat, and it's no longer a triangle. It's just a flat one. It's 18 So what happens when I lift this up? Does that point get longer or shorter? So if it got shorter than 18, this level, I should have set between this. This is so if I come in, so this is like Easiest term possible. Not still 11, still 7. Okay. What did you think the first time?
Oh no!
I didn't know. So yeah, you imagine the 11 and the 7.
Sorry. I got you.
No, because it will fall exactly on. Like, if this part would fall exactly on.
And that's not
That was 19.
this getting closer to that point. Hold on. I think you just discussed this point to that.
What is that?
Are you getting closer or farther? This to here. We're getting closer.
What is this?
Ooh, okay, now I understand what you mean. So, yeah, this is definitely smaller than 18. Still definitely smaller. Because if this is 18,
Why is this not? So it has to be.
and that tells another restriction of a side that wouldn't be. Sweet.
You gotta explain.
All right, so this slide seems pretty insightful. There's a range of lengths that work in between two ranges of lengths that don't work. Very interesting. And what did you guys say about it? Green bars between 5 and 10. The two lengths have to be more than base turn. 5 and 1. All right. I'm not going to give feedback on whether these things are right or wrong right now because we're in the process of learning, right? Confusion happens right before learning. Lengths add up to more than the bottom number, which is 8. The measurements add up in specific ways. Hard to explain. I agree. It is hard to explain. Length of the green side has to be more than the added up with 3 to be greater than 8. And it has to be less than the red side and the base. Whew, a lot of details there. After 11 and before 5, all the tires equal to X. You didn't have to admit that was yours, Rochelle Gutierrez. 8 plus 3 equals 11. I agree. 8 minus 3 equals 5. Okay, I agree. Anything in between 5 and... Okay, so even answers like this, Jaime Escalante, I don't know if you're telling me that my side could be 5 and it could be 11, or can it not be 5 and can it not be 11? Or could it be one of them and not the other? Like, I hear what you're saying and your math is true, but I don't know what you actually mean. All right, keep going. I want to give you a couple more minutes before we try to formalize this. I like some of these challenges you guys are making. Hey, Nolan, do you still have the Desmos up? Nolan left.
So
Nolan left the room for a minute.
So like, wait, like in what way? That's what I'm saying. How do you know? So let's just say like 5 on the bottom.
Easier to
No, then we could just do that. Okay.
Nolan,
Yes.
your slide 12 has one mismarked. I would challenge you to figure out which one you mismarked. All right, so this is an interesting slide that I think we should talk about for a moment. Now, a few of you are back here before me, but I think most of us are like figuring this out and we're just taking kind of different paces to get through it, or some of you are bouncing around. It's honestly a lot to keep track of. Because, guys, you're all anonymized now, but my summary view is like all of you and exactly where you are, and you're bouncing back and forth. But, all right, so here, Abina makes her first side 12 units long. She would like her perimeter to be 24. So, let's say this is our 12. Let's say that's our 12. 4 of these. So these are my grandpa's old measuring, not tape, because these days obviously we have measuring tapes. And actually these were probably great grandpa's potentially, but this was a measuring tape before we had measuring tapes. Right? So you could fold this up, stick it in the closet, it wasn't crazy, but this, when they latch into place, it's accurate measurement. So yeah, this thing is kind of cool. I got a couple of them because they came from grandpa's tools. Let's say this is our 12. Anyone want to talk to me about, can I make a triangle with a perimeter of 24 now? Anyone have real strong opinions about this slide? A lot of us are past this slide. Our base is 12, so ignore this part. I should really hide it back there. Vivian?
I think you can.
Okay, say more.
Because if you have like the other side before, you get to 16 and then you can have 8, which is between 12 and 4.
Alright, so you said do, this is why I tried to make the math nice. You said do a side of 4, so that would be, it's not visually perfect, but alright, a side of 4, and then our other side would be 8. Okay, so 4, what is 4 plus 8?
That is
12. So when I go, to, I need this endpoint to get out to here.
It's too much.
Say more, Jack.
I found out that the equal, like, these two sides, whatever they're called, they have to add up to at least more than the perimeter and this side. Well, the perimeter and this side, minusing this side, but it has to be less than both of those sides combined.
Who thinks they kind of have figured out what's going on, but it's hard to explain? Yeah, it's really hard to explain. So, alright. Blank page. I really think I need to go back and make that say blank space, because it would just be funny. Let's start with 12. Let's just say that's our given. I guess I'll make it green. Alright, so that, let's do this too. I don't think excuse me, I don't think I have to pause you guys, but like, stick with me for a moment. Because even if you got this slide right, that you could have gotten that right by accident. So we make the base of our triangle 12. We're trying to make a perimeter of 24. So that leaves us with how much left to work with? 12. We got 12 left to work with. So our first idea was do a side of 4, which leaves us with how much left? 8. So the question is 8 enough to get from here? Now, has anyone ever heard the phrase, how the crow flies? Like, grandmas or grandpas would maybe say this. They'd be like, oh, well, it's only 2 miles how the crow flies, but you're going to have to drive 10 to get there. So, how the crow flies is an old Appalachian saying for if you could fly and get there in a straight line. Do you know what the gist of the saying means? Give me the gist. What's it mean?
And you can get to any 2 point from any point A to point B with a straight line, but that's not possible since we are feeble ground humans that can't fly. So
All right.
we have to take weird ways.
Now that you're insulting us, that we're feeble ground humans. All right, so here's Phoenix. Right, here's our school. If I could fly, my route home would be that far. Unfortunately, I'm a feeble ground human, and I have to pull my car out of the parking lot, go down the road. I'm not going to say road names because we're recording this for the internet. And then I get home. Which is shorter, the green line or the yellow lines?
Green line.
This is the gist of how the crow flies. If you can do a straight line between 2 points, it's the shortest connection between them. So if we come back to our 12 and our 4 and our 8, will that 8 reach the end of our 12? It could.
It could, but it would just end out being completely flat. So it could have.
Ooh.
The maximum would be 7.
It could, but to do that, we would have 4 and then 8. And do we have a triangle? No. So this is where go to Schoology. Whatever tab you have open, it's not on this screen. This is a problem with 2 screens. The triangle inequality theorem tells us any 2 sides of a triangle have to be greater, not equal, because equal disappears into a straight line. You need to be greater to become a triangle. Like, these were equal, but now when I bump it up to a triangle, it does not connect. It's not big enough. I need to go greater. And I got a lot of options, but is there a maximum length? Yeah, eventually it'd be too long, and I can no longer make a triangle again because it's too long. So I want you guys to pop over to Khan now. Let's take like 5 minutes maybe. Try the triangle activity. I just want you to get a feel for this, see what struggles we might be having. I want you to like raise hands, ask questions if you need to. Then we'll talk a little bit about cross sections. But any 2 sides of the triangle have to be greater than the third. Not equal to, greater. Lydia, why are you going to map recommended practice? Sorry, your screen went there somehow on its own.
It always goes automatically to that recommended practice, and I have to click the logo of Khan Academy to get to my logo.
So there is another little, like, not trick, I hate that word. As you guys start answering those, like, what are the possible third side lengths? Like, what is the restriction? I bet you'll figure out this little, like, rule. I guess we could call it a rule. So take a couple minutes, and then I want to see if we can formalize that rule. You're not paying attention to what I'm doing either.
Just get one answer wrong, and then at least you have
So, what we just said, and what Schoology showed us, is two sides added up have to be greater than 1/3. And we can try this all three different ways of adding up those sides. So, is 7.7 plus 4.0 greater than 1.7? Yes, that's obvious. Is 1.7 plus 4 greater than 7.7? Then can this be a triangle? Then they would do. Yeah, that's good. We're just applying that whole we have to be greater. Now this is why I'm writing that side. Alright guys, apparently I can't tie my shoe. I've retied this shoe like 6 times today. It sounds like a dangerous decision. What about when I really need to take my shoes off? I finally got smart and started assigning the same work to myself, so I can pull up like your homework. There's a, I don't want to call it a trick, but there is a trick to like how to just like, oh yeah, all I do is win no matter what. No? I need someone to help me with figuring out how I can get these values, my restriction boundary points. Madeline talked me through one of them. Kyrie talked me through the other. Sorry, I'm looking at both of you at the same time. I caught it. Well, I know, but Kyrie raised her hand. All right, Madeline, do you want to do the lower one or the higher one? The lower one? All right, what do you got? 8.8 and 8.
So subtract 8 from 8.8.
Okay. So 8.8 minus 8 is 0.8. Okay, what do I do with that 0.8? Can that be my third side length? Can 0.8 be my third side?
Wait, oh no. It has to be, wait, it has to be bigger than that.
So, this is why, hey guys, don't make me lock your computer screens. It keeps like not unlocking and stuff like that. I don't want to have to do that anymore. We had a bunch of glitches yesterday. I'm kind of annoyed at Securely. This identifier is a huge, like, critical thing. The less than does not involve the or, right? So when you did that 8.8 minus 8, like for example on this one, and you got 0.8, that 0.8 is what would take your triangle and like crush it back to a straight line. If you try to use that 0.8, that's when like, and it flattens out and it's no longer a triangle, it's just a straight line. To make the triangle actually able to work, you got to be bigger. So this side is our difference, right? We literally subtract, take big minus small. Kyrie, what about the other side?
And then the other side, you have to add 8.88.
Okay.
16.8, and that's and I can't, and your x cannot go over that number and stuff, because otherwise it won't work.
And that is the situation. I know this thing's a little clunky, but I like paying tribute to my grandpa and using these old things. So, if I have a triangle and I get a longer third side, that's fine a lot of times. But what if my second side, and by the way, the names of first, second, third, those don't really matter. What if my first side, I need to share some of this. I mean, I could make it really dramatic and just break it there. Will this form a triangle?
No.
I mean, yeah, but with a ton left over, right? Or, guys, essentially then what happens is the same situation of the side being too short. It's like, can I stretch? No, it doesn't work, right? Here's our trick. It's the difference and the sum, right? It's literally the minimum boundary point that is not allowed to be the length of your triangle. You can't use it, is the difference. Anything bigger than that, up to the sum. Try a couple more of those questions to make sure you're feeling okay. Then we will talk about cross sections for a moment. Oh, I forgot my flashlight. One of these days, I'm gonna actually get a lightsaber when I'm at the school. I just need to find one for cheap. Here is my lightsaber. I probably should hold down here. Here is my lightsaber. It does not, because I forgot my flashlight at home. That was one of those things. Yeah, and then this end has, well, this fell out apparently. One of the ends had the reflective thing from a flashlight. All right, so this goes back to when Phoenix had our construction and all the parents had to drop kids off to a new place in the middle of winter. I literally put a flashlight in this thing and I was directing traffic, like trying to use it, because it was really dark out in that parking lot. Cross sections. Let's talk about cross sections. Let's imagine I take my coffee mug and my lightsaber, and I lightsaber straight through my coffee mug. And it's a lightsaber, it cuts through anything. And then I, take apart the top half from the bottom half that has now been cut in half. You gotta imagine a bit. You gotta get back to your childhood and imagine a bit. What shape would be at the cut that the lightsaber left, which if you watch Star Wars, will glow red for a second because it just got cut through. What shape would that be here? Anybody? So, here's the trick. It was a cylinder. It was 3D. But cross-sections are two-dimensional slices of a 3D object. So, my coffee mug example, you'd still have two cylinders, right? You'd still have that. However, the cross-section is where the cut happened. What 2D shape resulted from that cut? So here, if I cut straight across, what shape would I get? Circle, right? Like it shows in our Schoology notes. But that's not the only shape that you get out of a cylinder. The trap door that people fall into is a cylinder is made out of a circle. That's all we get. But what if I slice it vertically? What shape do I get then? A rectangle. Now stick with me. What if I slice it diagonally? Harrison, say it louder. An ellipse, which in writing is the ... That's called an ellipse. But in math, what's an ellipse?
It's an oval.
Yeah, it's like a circle that's not a circle, right? So it's an oval, right? An oblong circle. So any 3D object can be sliced in almost any direction. And this gets really tricky. I don't know if I want to do this today or not. I only have 4 minutes, and that definitely won't be long enough to get far into it. I might start showing it to you, because I know some of you are going to go to that act. Some of you are already trying the volume activity, and that's way not today's homework. Yeah, I see what you're doing. All right, I wanna tease a little bit here. Did I leave it open? That's the question. Oh, I have so many tabs. Guys, don't be like me. Don't be like me. I don't know if I left it open. I don't know if I'll be able to find it quick enough. I did not plan on doing this today. That's why. All right, here's our Math 7 problem about a composting toilet. Yeah, I know. It's weird. All right, let me see if I can find it super fast. You guys just do whatever you're doing for a minute.
Okay.
I thought I had it in my spreadsheet. Ha! Found it. Alright, I again do not want to pause your computer. But I do want you to all come with me for a moment to be able to talk with your partners. Put your binder on your desk. Quit packing up early. It's really starting to become an annoyance because I need every minute of class. If given a cube and a lightsaber, no, I'm not giving you a lightsaber, sorry. What shapes can I create by slicing through a cross-section of the cube? I want to see which group can list out the most. So somebody get something to write on, or type, I guess, if you want to open a Google Doc. So what's the first obvious cross-section we could slice? A square. Duh. Sorry, I don't like that word. But duh, it's made of a square. We can make a square. What else could you make by slicing cross? Talk with your partner. Try to make the longest list you can. Longest list you can. You can slice at whatever angle you want, but it's a straight slice. Whatever angle you want. If you don't know what to call it, just say a 7-gon or what as one slice of the square. You just did a different slice from the original cube. Another different slice. No, on cross section is one slice of straight through. No, because then you'd be starting with a different shape. We always have to start with a cube. So, if you slice it once, then can you use the new 3D shape? No. I don't know exactly what you're asking. Let me put this up on the screen, see if it helps. Hey, just to get you thinking before we get out of here. Because we're gonna get out of here. Hold on. So here's cut 1. It's kind of obvious, and you can look at it from different angles. Right? We can spin this around. But here's cut option 2. Here's cut option 3. Get out of here. We'll pick this up on Thursday. Have a great day. I see some of your minds being blown right in this moment. Wait, 1, 2, 3, 4, 5, 6? It is a hexagon. It's a not regular hexagon. Quit thinking that all hexagons are regular. That's like thinking all middle schoolers are the same. That's just not true.